So, guys, thank you everyone, and welcome for today's webinar. This topic is about Smart Together AI's promise for a fully coordinated BIM-Spec future. My name is Manish. I work as the Associate Vice President with Virtual Building Studio. I'm glad to have you all with us. At Virtual Building Studio, we provide top-refined architects, MEP structural modelers, and half the market course. I would also like to extend a warm welcome to guest speaker, Matt Johnson, the Director of Manufacturer Solution at RIP Software. So for years, the industry has aimed to create a seamless connection between BIM models and project specification, but most attempts have ended with fragmented tools and incomplete automation. By the end of the session, you'll learn why BIM-Spec's automation struggle, how to use the Gartner Hype curve to judge new technologies, why coordination, not full automation, is realistic and valuable goal, and how AI can support human expertise, not replace it. So the expert is right here, and I'll let Matt do the talking. Matt, back to you.
Well, Manish, thank you. And thanks for having me. So by way of introduction, again, I'm Matt Johnson. I'm the Director of Manufacturer Solutions at RIB, which stands for Revolution in Building. I've been designing and building software for over 35 years at this point, with a focus on products built in support of construction specifications. Worn a lot of hats during that time. I've been programming even pre-internet, if you can believe that. Owned one of the first programming boot camps about 25 years ago. Even had an AM radio show for a time where we talked about technology, and spent a number of years working for venture capital companies doing project turnarounds at startups when they were taking too long to bring a product out to market and burning through their cash. So again, worn a lot of hats. In a former life, I actually built the original building product manufacturer program and technology stack at MasterSpec, serving as their chief technology officer and as a member of their board of directors before we sold to Alpine, and which was later flipped to Deltek. More recently, I've been focused on advancing the capabilities of RIB platforms such as SpecLink and SpecLive, and extending the functionality of both platforms to include a new suite of building product manufacturer tools that enable digital specification management and collaboration between specification reps. And that includes an API that's being used to create specifications directly from Revit, which we'll take a brief look at a little bit later. Also had an opportunity to serve as the American delegate to the International Construction Information Society. That gave me an opportunity to collaborate on international efforts aimed at improving coordination between BIM and specifications. So what I'm going to be stepping through today is really taken from two longer presentations. I think combined they're probably about 6 hours, and I'm not going to flick that on the audience here, but hopefully pull in some of the things that are most relevant. The first is Moneyball for building product manufacturers, and that's really designed to take a deep dive into a number of different platforms that are designed to get products specified. So we take kind of a critical look from a technology and investor perspective to see what actually works and why. And the second is called Solving for the Ecosystem. And that was really created to help explain, and it's kind of germane to what we're talking about today, why technology predictions are so often wrong, and hopefully help us do a better job at evaluating risk when it comes to emerging technologies. So I chose today's topic, AI's promise for a fully coordinated BIM-Spec future, because I'm finally seeing some movement on what's possible. There are AI tools available that can finally help solve some of our toughest problems, potentially not in the way that companies are trying to solve them currently, but there are some capabilities out there that I think will bring maybe less automation and more collaboration with human experts still in the loop. I'm a big believer in trying to help our spec writers and architects and engineers be more efficient and not be replaced. And so a lot of the things that I'm going to show you here kind of have that in mind. So, and I'm going to say, because I've had the opportunity to check in on a lot of the development efforts in our industry, not just what's going on at RIB, and I'm familiar with a lot of those players and other startups and grad students. I need to be somewhat respectful of being too specific about who's doing what. So I want to make it clear from the beginning that I'll have to be a little bit general in some areas when talking about a specific effort or capability. But if there's anything you'd like more detail on, please reach out to me via email or LinkedIn. Be happy to work with you. And to be clear, kind of where we're going today, this isn't a warm-up for a new product announcement. I don't really feel like I can do a deep dive and explain why there were so many broken promises that usually began with a carefully curated product demo showing capabilities that didn't quite deliver in the real world. Couldn't do that and then follow up with a similar format. So I'd really like to state the goal up front that I'd like to put you in a better position to evaluate BIM, spec, and AI related technology from any provider going forward, not just RIB. For those of you not familiar with RIB, I'll give you the quick 60-second overview. We have over 27,000 users, using our content and editing and collaboration platform called SpecLink. We put through more than 60,000 projects a year, and it probably is maybe about 40% of the commercial construction market in North America. And so that's built for the architect, engineer, consultant, owner community. And we also have a program for building product manufacturers called Spec Live. And we have about 750 participating manufacturers in that program. SpecLink itself really serves as a collaboration hub. We have a place where multiple stakeholders can access and work on a project. And we keep all the content up to date for them with regular updates on standards and things of this nature. So one of the things first things I built when I moved to RIB was the ability to ingest master spec content and manage it within the platform. So a good deal of the content that originated from master spec that you might see on Construct, Connect, or Dodge, a lot of that's managed within SpecLink. And we have an amazing set of tools for BPM, which is not the subject of our presentation today, but I'll be happy to show you if you'd like to reach out after the webinar. Now, when it comes to BIM, RIB does deliver on BIM in a few different ways. For our SpecLink users, we have the ability to analyze a model and help you map it to the sections and product types needed when you build your project. In the next few days, look for some announcements. I don't want to steal anybody's thunder, but look for some announcements from RIB on this front. They made some significant improvements to those capabilities, and especially when it comes to their viewer. Does everybody understands Revit licenses are pretty expensive, and it's nice to have a viewer that lets you see the model without having to have another license. So making some great strides that way. What you're seeing on the screen here is an API that we actually use for our building product manufacturers. And this API is used to automatically create finished specifications from Revit. Now, this video is from one of two Revit plugins built by USG. So you can go to their site, you can download their Revit plugin, and any user, not just a SpecLink subscriber, can use that free plugin to create a detailed ceiling in Revit with the accompanying BIM content and deliver coordinated specs that exactly match the design. And that typically takes somewhere between 3 and 5 seconds. They have a similar plugin for wall and floor assemblies, which you're seeing here. So this API has also been used to automate the process of writing general guide specs, but that's been a little bit more of a pilot project by one of our larger owners that builds fulfillment centers and is a little bit better positioned to kind of build variations on a theme and make that concept work effectively. So before I jump back to our primary subject today, kind of like the obligatory NASCAR slide here, our goal at RIB is really more focused on customer retention than acquisition. And it's one of the reasons that I do some of these presentations. Having spent so much time in product, it's really surprising how many new ideas we need to say no to and not get overruled by management. So I can't tell you the number of things that we could have done at Master Spec that I blocked because while it would have helped us chase the latest hot topic they were asking for, there's a lot of things in BIM and sustainability that kind of fit in that kind of category. I knew that eventually I'd have to show some results. So I potentially ruin that relationship. And I see the same people year after year at AIA, and it takes a long time to build that level of trust. RIB pretty careful about what they introduce. And I think that's the right approach. We have a great product team here, and they're very cautious about making promises that they aren't absolutely sure that they can deliver on. So back to today's topic here. So the goal is not to just give you some insight into what's coming, but kind of take you through my journey as well, and figure out, like, why did the original attempts to what we might call best practices BIM, this idea that the model was going to inform all other parts of the design cycle, primarily specifications, why did it come up short? I think we all understand that BIM is used in a lot of different areas today. What I'm primarily focused on is the original promise of using a BIM model as the single source of truth that makes the creation of the spec near automatic, or at least a lot easier, and why it's important to understand what didn't work as we architect future solutions. And I recognize that a lot of people joining us today are going to be part of the decision-making process for selecting platforms and technologies for their respective firms. And I'd like to give you some tools that you can use to help explain how you might evaluate whether something is safe or risky for a particular platform. Now, I work with a lot of very well-informed people that have done their research, but ultimately, I think we all have to be accountable to someone, and a lot of the time that's an executive that is expecting some sort of a simple answer. Anything that has AI attached to it has got to be the way forward. And there's a reason why somewhere between 88 and 95% of all AI projects fail. And it's not the technology that's at fault. It's almost always the data and the product design that hasn't adapted. So there's some lessons in here. So hopefully you can help guide your firm to make a little bit more intelligent choices as new platforms and new opportunities come out over the next couple of years here. And finally, the way forward. What are firms working on, and what approaches show promise? And what's the most promising area we can expect to see a leap forward? And by leap forward, don't mean AI whitewashing, where you just kind of attach some sort of a basic AI capability to an existing product. I'm talking about really moving the needle and solving some of our industry's toughest problems. So, right from the beginning, going to throw the big question out there. We were told BIM-to-Spec was inevitable, and that BIM would function as the single source of truth for project data. What happened? So I need to make it clear that I tend to be kind of a skeptic. I'm a show me the data to prove it kind of guy. And I want to go back to my original introduction to the BIM-to-Spec dream. And it literally came in the first day that I was hired to start the new manufacturer division for MasterSpec. Up until that time, there really was no clearly defined process for getting new manufacturers and products into MasterSpec. We had almost 1,000 sections, and almost probably somewhere in the range of about 7,000 different individual product types, all with their own requirements and so forth for vetting different products to get people in. Oh, there we go. I consent. I just got the message about the webinar being recorded. So my primary focus was really on setting up the technology stack and cleaning up the data to make it possible to organize and run that side of things. But I was also asked to evaluate whether we should acquire or build our own platform to provide a complete BIM-to-Specs workflow. This is in an environment, if you'll remember, where everyone says that this coming change is just inevitable. If you're still doing specs the old way, you're going to be out of business if you don't make the jump soon enough. And there were existing platforms at the time, and they generally provided a limited library of generic objects that you could link to turn content on or off. And the technology did work. And, it was possible to sometimes introduce new BIM content, but it was a tedious process. And, most users didn't usually have the time for it. It also made it difficult for us to update the specification content because it had to be coordinated with the model at the same time. So the technology did work in that perfect scenario, but it just wasn't workable for how dynamic and changing the design process has to be. It struggles to be effective in those real world settings. So I was doubtful from the beginning that design firms would really constrain the entire way that they worked just to make the specification process a little easier. But what we needed to find was a more dynamic approach, since it was clear that the demand for this capability was just going to be overwhelming, or at least that's what we were told. So this is where I kind of need to go into what I would call my light bulb moment, where we really discovered there's a big disconnect from what we were told about the market and what was actually happening. So in 2014, I was at an International Construction Information Society conference in Tallinn, Estonia. Small group, maybe 40 individuals in attendance, all representing international companies focusing all or in part on specifications. And I was there representing the US as the CTO for ARCOM, Master-Spec at the time. And I was giving two presentations, one on sustainability and one on a separate spec API tool we built to build specs for MPI, Master Painters Institute. And if I could make a recommendation here, Tallinn, was never on my bucket list of places I wanted to visit. But if you love architecture like I do, I was just blown away by the beauty of the old city. It's in the old city's in close proximity to all the new or all the fairly new Soviet era architecture that surrounded it. One of my favorite memories was just wandering through the old city, 10:30 at night. It's bright, the sun's still out. And ran across this Depeche Mode bar. It's this tiny little hole in the wall that only plays Depeche Mode music, one of my favorite bands when I was a high schooler. Very unique experience, and the city has a lot of character. The conference was functioning as a technology and strategy show and tell, where each country would make a presentation on some subject related to construction information, usually related to BIM. And I want to focus specifically on a presentation from NBS in Great Britain. They had a great government-funded survey that they'd been putting together for some time. And at some point, I think a lot of people on the call here have maybe seen some of their data. And it provided a very detailed breakdown of where firms all over the world were with regard to BIM adoption. The report was very positive. It seemed clear from the responses that within the next 2 to 3 years, the majority of companies surveyed were going to be using BIM. The subtext being that as specification providers, we were going to get left behind if we didn't provide a level of automation between the model and the specs. Firms were going to demand it. The survey created an impression that if you took companies at their word, 93% of companies were going to be using BIM by 2017. So one of the job titles I held in the past was Director of Marketing. And so I had a little bit different perspective on the survey that I was seeing. And so we had one of the people that put together the survey there, and I started asking, more specific questions about the types of questions they were asking, specific phrasing. What did you mean committed to BIM? To me, it sounded like, what we call a push survey. Something where you're kind of asking very general questions designed to get the answer you want in order to give a favorable impression about the market your core product is in, specifically how fast the user uptake will be. So in the afternoon, we had another presentation, this one from Skanska. And they weren't there for to see those numbers where it was just inevitable, where everybody was using it. At the time, they were saying 65, 67% of people are currently using BIM, and it's going to raise up into the high 90s within 3 years. So Skanska kind of showed how they were using BIM, and they are probably the best example of a company that can do it and do it well because they own the whole process. Whereas, we have, different groups that in some ways are almost a little bit adversarial here in the US. They do everything kind of soup to nuts. And so they're the perfect place to make a fully integrated BIM workflow work well, because you could have somebody at the beginning of the process invest a lot more to make it easier for somebody at the end of the process, something that's difficult in other circumstances. So they showed that it was employed for everyone along the design path. They could have the team building the model do the extra work to make sure that they only used a BIM library that had all the detail to assist the other phases of the project. The representative provided a surface picture of the entire organization's commitment to BIM, pictures of GCs on site with the architect reviewing plans on an iPad, for example. And what we got was that sales pitch, the presentation that I'm sure they provided to prospective clients. So I asked, how many projects are using BIM? And of course, they said all of them. So of course, using BIM, it's a really broad, non-specific statement. and I asked, how are you using BIM the way you described in your presentation, not just occasionally, throughout the process? And after some back and forth, they admitted that within the next couple of years, they were hoping to get to 0.5%. And there was literally like a gasp from the attendees, the juxtaposition of 65% versus the perfect, user, circumstance for the whole flow, not even being at 1%. And I thought it was just, the perfect comparison between the two. You can have a survey that gives the impression the whole world has their act together, and your firm will get left behind if you don't act quickly. And then you compare that to what is widely regarded as the standard bearer for fully embracing BIM throughout all phases of construction. And it was at that point I really started to have my doubts about the inevitability of automated specs. So it looks like an expectation had really been created, and created an impression that everyone had a level of commitment that didn't really exist. But what about the software side of the equation? Where was that platform that could hopefully make the whole process easy enough that firms could jump in and make it work? So we were told BIM-to-Spec was inevitable and that BIM would function as that single source of truth for project data. I think it's clear there was an effort to overstate the inevitability of this. But, what about all those big promises that were made about the software? So I'm going to take a moment to answer that by briefly describing the Dunning-Kruger effect. And I'm sure this is something that most people in this call are familiar with. And even if you're not familiar, you'll probably recognize it in actual practice. And this is where, in the field of psychology, it demonstrates a cognitive bias where people with low ability or knowledge at a task tend to overestimate or underestimate how easy it's going to be to solve the problem. They overestimate their ability to solve it. They just don't have enough subject matter expertise to recognize just how much they don't know. And so if you were on day one of, let's just say, architecture school, and you ask somebody who's taken a single class, hey, how would you solve this? Is this going to be tough? They're going to say, yeah, absolutely. And they would explain how. And an expert would really hedge their bets and go through and explain, man, there's so much we don't know about the problem, and they'd be a lot more careful in their approach. And so, they've mapped out a lot of these different phases of, being able to problem solve. And you tend to start off with what they kind of call the peak of Mount Stupid, where you're, the least amount about solving a problem. And then it drops into what they refer to as the valley of despair. Hey, I've learned enough to say, man, this is going to be way more complicated than I thought. And then there's a slope of enlightenment. And this is where, you learn enough to say, I might not be able to deliver the wild promise that I originally started with, but we can, deliver some things that are useful. And then eventually you get to the point where, enough has been learned that, you've got kind of a sustainable plateau for adoption. Now, the Gartner Hype Cycle is really critical for when it comes to taking a look at new technologies and managing risk. And Dunning-Kruger is kind of, you'll recognize some similarities here to the way that the Gartner Hype Cycle is kind of laid out. Now, 100% of new technologies, they go through, all these same steps, and it ties in a lot with what's needed for investment. There's usually a technology trigger phase, and this is where, things tend to kick off. It's proof of concept stories and so forth. And, the media might start to, jump in and talk about this exciting new technology. And usually when you start seeing a few individual success stories, that's what we call the peak of inflated expectations. It's where this looks like it's just a runaway train. It's just inevitable. And you can see that some people are out there making it work. Behind the scenes, they're usually making it work in a very narrowly tailored set of circumstances, usually, targeted towards gaining customers or, in a lot of cases, gaining investors. And it's an important note here that technology needs this step. We really do need 30 companies to jump in and think it's going to be easy to solve a problem. So we get the one or two performers that make it through to the other side and can kind of deliver. And we see this happen over and over again. And as an informed investor, you need to be able to recognize the different phases, because if you're not an early adopter and, you're okay with a lot of these, early promises kind of falling by the wayside, it's very dangerous to engage a new technology at this stage. Normally when something comes through the other side and it drops into that trough of disillusionment, you got to love these names. That's when the real world steps in. They've taken their application and they've tried to make it work in the real world, and they find out, man, there are all types of problems and so forth. And eventually they learn enough that they can start to deliver a little bit more constrained results, based on those things. And again, as an investor, you need to see where your company fits. If you're a software developer or you're developing tools internally, you might have a little bit more of a toleration for things that are a little bit more bleeding edge. But if you're looking for something where you really can't afford to strike out, you don't have that kind of latitude, you're going to want to use technologies that are a little bit farther along on that hype cycle. So on this graph, I've given some BIM examples. And, you can see we are, effectively using it in a few different areas here. But a lot of the really exciting core concepts, the BIM-to-Specs and so forth, are nowhere near, being viable. In fact, I think you can make an argument that they're probably a little bit closer to the bottom and not close to making a turnaround there. And there's, AI equivalents here. So rather than kind of redoing my graphic, I kind of laid those both side by side so we could point out a couple key ones that I think most of us are familiar with in some way, shape, or form. You'll notice, for example, generative AI. If you're using Grok, it's falling into the trough of disillusionment. I think there'll probably be some pushback on that. I love a lot of these new agents, but I think for the most part, is people are moving from, hey, it can solve anything, to a lot of real world scenarios. This is where, outside of the tight confines of, the app that it's used on, you find out that when you try to use it in your company and with real world data, that it tends to be a little bit, more constrained. There's other things in there like, AI ready data. People tend to really underestimate that one. That's one we're going to be taking a look at here. AI agents is one that's supposed to crash a little bit. If you've used any of these workflows like N8N, I absolutely love some of these. I think that there's a great future ahead, but I think there's a little bit of a come down as far as the capabilities there and so forth. And then one of the other things that's going to be germane to what I'm going to show you here is artificial general intelligence. There's so much in that last mile that we still expect humans to fill the gap on, that artificial general intelligence is really what people are waiting on. They expect that it's going to be at least 10 years, before we really see any movement on that. So with, all these advancements, how come we haven't been able to solve this yet? So, kind of the first pass didn't work. How come in the ensuing, 10 years, we really haven't seen any big leaps forward? Well, I wanted to address that and break it down specifically. So rather than just kind of point to what didn't work, I wanted to be kind of specific about some of the challenges here and why the original plan is probably not going to happen. So one of the things that's left unstated, a lot of the time they think that large companies are the ones that are going to go through and solve a lot of these things, and that's generally not the case. Larger companies tend to be a little bit more risk averse. You need startups to be able to jump in and tackle a lot of these issues. They tend to be the ones that embrace things that are a little bit more risky. It doesn't make sense for larger firms, and I didn't put it on here because I didn't want it on a printed slide. But a lot of the time when we're bringing those types of solutions, people don't take into account the investment horizon of the executives. If they've got to go through and make an investment in something and they're judged on the next couple quarters of performance, it's very hard to do something risky that isn't really going to have a payoff for 2 to 3 years. It really takes a coordinated effort to do that. So, there's not a lot of startup firms that are trying to solve that problem. I think here in the US, everybody understand that design, bid, build separation is a major challenge. If you're asking somebody at the beginning of the process to very carefully put together a model to make something easier for someone later on, that's a tough ask. when we take a look at Europe or some other places, they actually have some things that are forcing BIM adoption. But even in those cases, they're kind of working around it. It's a lot more common to build things in the traditional way, and then at the end, put together the whole model based on kind of the final product and so on, which I think is certainly a lot more common. And then one of those unstated things is, in a lot of cases, having done hundreds and hundreds of individual installs, in my formative years, you notice a little bit of a pattern. Everybody says that they're on board. Everybody says, hey, I agree, this is what we need to do. And then for the most part, people tend to drag their feet. The switching costs are high. And a lot of the time, systems that are a little bit archaic and difficult to use, everybody recognizes that you need to move into something that's a little bit easier to manage. But the very people that need to be able to make those systems work, you're kind of working to make them less critical to the process. So that tends to be something that people don't look at. And then these last two ones are things that most people are not aware of. And I'm going to focus on these last two because they really are the blocking issues. And they're what I would say is the best opportunity for where the pivot's going to come from. And kind of changing what we're trying to accomplish. So the limited ability to implement a best practices workflow, this is essentially saying, and think back to the companies that were using some of those earlier products. I'm going to run my entire project where I'm just going to use this limited library of BIM content that is going to turn on this, content later on in the process. There's very few companies that are willing to do that. And even the ones that build variations on a box, in other words, every project's not different, they're doing something relatively similar. Even those have tried it with a lot of fanfare and kind of backed off over the years. The other one here is what I would call the HAL 9000 problem. And this is where I kind of show my age a little bit. I need a more up-to-date reference. But this is the general intelligence. It's the smarts that solve everything else that we can't automate. And so these two pieces of key enabling technology are really what's needed to solve the problem. One is solvable, one is not. It isn't going to be solvable anytime soon. And the first is normalization and classification. Like, we've gotten to the point with AI that we can spot a lot of things that weren't properly accounted for. So imagine you've got a lot of BIM content there, and somebody hasn't gone through and put in the right keynotes and ways of identifying that. We've gotten pretty good at being able to identify what that is. Not perfect, but there are some methods to be able to make that a lot smarter. And some ways that we can take a look at humans that go through and say, yes, that is a specific type of door, and map it to the correct areas, and we can learn from that and make it a lot smarter kind of going forward. So we can solve that one, but we can't really solve the additional editing problem. And we're a long way from it, which sort of limits what it is that we can do. So to give you a little bit of an example, this chart kind of lays all these pieces out. A lot of the time when I'm doing this presentation, this is where people might jump up and take a picture to kind of explain, what's going on here. So there's a number of different axes here, and I'm going to kind of explain what they mean. From a perspective of development complexity, there are certain things that we can deliver that get increasingly complex. Being able to, deliver full general intelligence, to be able to go through and say, all right, we've seen what's in the model, but what are all the other things that go on? Understanding the local building codes and, what the owner wants, and, all these little idiosyncrasies that are involved in writing each individual spec. All that last mile stuff, we're nowhere close to. And so I've mapped that as almost 100% as far as development complexity. And that's what's needed to really deliver full automation. And even though 100% of firms would be interested in it, there's really only 2 to 5% that would really be willing to do it anyway. So this is that narrow band of companies that can say, hey, we're going to do everything in a very tightly tailored framework. We're never going to cut corners because we're moving fast or we're trying to meet a deadline. And so even though just about 100% of firms would be interested in that, very few firms can actually support it. But there's another thing that we should be pivoting to, and it's focused a little bit more on gap analysis. And so we can solve normalization in classification. And so this is a lot more of a worthwhile target. It's really built around reducing the friction between the model and the spec writer. I'd kind of use a little bit of a tennis court analogy. There might be 700 individual questions about a specific product originating in the model or the spec. That model might originally just show a door, for example, and later on, at a higher level of design, it's a steel door. Later on, it might become a fire-rated steel door. So each of these decision paths needs to be tracked. And this is critical. The spec writer is not going to allow anything automatic to happen in the spec. They're just the gatekeeper. And the modeler, the reviteur, can make a request, but I've never met a spec writer that is going to allow an outside process to come in and change the language of a legal document that they have the ultimate liability for. So this is where that red line kind of stops us at gap analysis. And the idea is to use normalization and classification of not just the spec, but Revit and a lot of the other tools that want to kind of inform the spec to put it right in front of the spec writer and show where the gaps are. What's different in the model from what's in the spec? So kind of, breaking this down and kind of showing how some things like this might work. We'll talk about how AI might potentially be able to solve this problem here. Being able to move to a little bit more of a gap analysis, talk about project coordination approach rather than, hey, we're going to fully automate the spec. So we really haven't seen any movement or new platforms to address this problem in quite a while. And so, I'm going to take just a moment to talk about how excited everybody was. And I think people remember this when we first reached that tipping point with ChatGPT. Everybody I knew was trying to see whether or not it could solve that one big issue that had been on everybody's mind. Can we use it to write specs? I think that at one time I counted maybe 5 or 6 different independent efforts at RIB just trying to see if that would work. And to be honest, is it ever going to work? In a word, no, it's not, at least not anytime soon. And there's 3 reasons why you can't use AI to put together a general guide spec. The first is that you really can't tell good specs from bad. Now, you might have thousands of different examples of a specific section being written, but you can't compare. You don't know why that section was written a certain way, why certain things were changed to meet local building codes. There's no parallel record that says why the edits and decisions were made in a particular section. So we can take a look at how well large language models and generative AI might write some sort of a free-form piece of marketing content, but they're just trying to write the most common way that it's done. What you really need is a way to say, hey, here's the most common way that it's written and a way to make the changes for the individual project. And we don't really have the tools in place for the way it needs to be done. The second one is, and most people don't think about this, is it wouldn't save the spec writer any time. And this tends to surprise people a little bit, but when you're trying to decide, do I spend a lot of money to make something like this work? It's the first thing that you should consider. So if we were to compare what a spec writer does to, let's say somebody's job, it was to spot landmines in a field. And, just for argument's sake, you've got 100 10 by 10, grids, and, there's going to be about 15 landmines in there. And, you come up with an AI that is 85% effective at spotting landmines, to kind of follow through the analogy. And the answer is, how much time does that save the spec writer? AI in the medical field that gets it right 85% of the time is fantastic. It's a huge leap forward. But, the spec writer, if you think about it, doesn't know what's right and what isn't. So they still have to check every single one of those 10 by 10 squares. Just because it's effective in spotting, potential problems 85% of the time, it doesn't save any time. You could potentially use it as an error check afterwards. One of the things that we've seen, unfortunately, is that a lot of the time that tends to reduce, the effectiveness of these types of projects rather than improve it. We've certainly seen that in the medical field. When somebody goes through and the AI comes through and takes a look at something they haven't really paid attention to and does a quality check, they just kind of confirm rather than take full responsibility for it. And the third reason is that all work is derivative. If you're going to go through and write specs, there are already tracking systems that are out there that, to be honest, if you're not paying for a library, they're going to catch you and come back and charge you anyway. So it's one of those things where, people tend to look at that and think they can work outside the system, and begs the question, it doesn't necessarily save you a lot of time that way. So there are ways that we can actually automatically write specs, and everybody just moved on from thinking in terms of automatic specs and ignored that there are some scenarios where we can actually do a lot of good. For example, this is an example of something that will work. A lot of building product manufacturers spend fantastic amounts of time evaluating specs, trying to get substitutions and responding to requests for information and things like this. This is a markup describing a CD&E process: complies, deviates, exceptions. And I've talked to clients that this takes anywhere from an hour to 5 or 6 hours, and it's very time intensive and time consuming, but it's perfectly set up for the type of pivot that we need. The user lives in only 1 or 2 sections. They can become that trusted user that sees a section come in. They can identify, yes, these are the products that I'm seeing come in, and kind of approve that, yes, this is what's in there. They can map, these are the products that we want to suggest. Here's maybe even the strategy. Is it going to be, the most cost-effective one? What do we know about the project, and what do we want to propose as an alternative? That's something that you can use within those narrow confines to have the user work within a system where you can see how they answer each question, and very quickly you can be automatically writing all that content for them. So as time goes on, the system gets smarter and smarter, and they're barely involved anymore, only for exceptions that the system doesn't know how to deal with. So getting back to kind of where we want to finish and wrap up before too long here is really talking about whether or not we're going to solve the BIM-to-Specs issue. So most of the projects that we see fail at about anywhere from 83 to 95%. And the reason they fail is because the underlying technology works, but it's with very tightly curated data. And so for those of you kind of taking a look and evaluating platforms, and you see somebody show you something that works great under that narrow set of circumstances, know that the odds are overwhelming that when you use your own data, it's going to be a disaster and it's not going to work. It's not because the underlying technology is wrong. It's because the AI technology is unsound. The data is imperfect. So by way of an example, I've got a daughter that's a senior database architect. She works in healthcare and works with massive data sets, and spend a lot of time looking more at project failures than project successes. But it's highly illustrative, and she's worked on 6 different AI projects. All 6 of them have failed, and they've been capitalized. In some cases, it numbers approaching like 8 figures, like a lot of money. And they come in and promise better patient outcomes, or being able to predict when hospital beds are going to be available and things like this. And executives are always very impressed that it works with that narrow data. And then they use their own data and very quickly find that it's almost worthless. And so it devolves into, in some cases, hundreds of offshore people quickly trying to fix things and so forth. It's very illustrative that in other industries, this problem is very, very similar. So we actually call this, going to introduce a term if you haven't heard it before. This is called a modern mechanical Turk. It's essentially, unintentionally faking AI. For those of you, forgot to capitalize the end there. So if you haven't heard of this, in 1769, there was this amazing chess-playing mechanical Turk that made its way through Europe. It stunned and awed spectators. It was like the first time they really saw what they thought was automation, some sort of a robot that could play chess. Not surprisingly, there was a human underneath that was, pretty good at chess, and they would kind of move the pieces around and perform the automation. Nobody would have been impressed without, the robot, the automated human that was doing it. But this has become kind of an industry term because what we're seeing now is so common. And I want to make it clear, I think the number of companies doing this intentionally from the beginning is probably near zero. Dunning-Kruger again. I don't think they get into it with the idea that they're going to pull the wool over people's eyes. They build an application using near perfect data or user circumstances. And when they move into the real world, they find out it just doesn't work with real data. So they employ hundreds of back-end people, to correct the data and preserve the illusion of an AI application. It's just a fallback, and they hope that eventually the technology will allow them to fix that, and it usually doesn't. If anybody remembers Amazon's just walk out stores, hey, you just grab a bunch of stuff and you walk out, and it's going to see what you pull from the shelves, and it's going to automatically charge your account. Literally, everybody knew we were laughing behind the scenes. We're like, we're going to find out in a few months that there's a bunch of people that, are examining those transactions. That's exactly what happened. According to reports, I think 700 out of every 1,000 transactions had to be manually checked. There was another company called Builder AI that, hey, you could go through and it would, you'd use their tools and it would automatically write code for you. And, what it really was 700 engineers in India that were fixing things every night to give the appearance and, probably preserve the investment. And hopefully, we can get along, long enough where the technology can deliver on that promise. But that's what happens to most of these projects out there. Now, we can pivot and we can learn from this, and this is how we can solve a lot of these issues. And we're seeing some companies kind of smarten up a little bit and take this approach. And you have to recognize that AI product design is really being done backwards. What we should be acknowledging is that the client data is always going to be incomplete and incorrect. Applications really should be designed from the ground up with this is the cornerstone, and make it easy for expert users to identify issues and correct them, and not just try to do it automatically just yet. We can take a difficult, time-consuming process and make it several orders of magnitude easier to solve while tracking how they solve it. And we can use the experts who are working more efficiently. We can see how they solve the problem so that AI can learn the right way to do it, to solve all these little individual issues. Now, I've heard this referred to as human in the loop, but that's not entirely accurate. The term could refer to any imperfect process that humans are expected to be that last line of defense and correct errors. But the system also needs to set up the problem in such a way that the model is being trained to recognize similar problems in the future and make better suggestions on how to solve them, or potentially have a confidence level high enough to solve the problem on its own at some point after enough input from humans on the proper way to handle it. So this is where I need to be a little bit careful, and we're getting close to the end here. About what I'm going to speak around. So I'm going to speak in some generalities without revealing who's necessarily working on what. In many ways, gap analysis really describes what spec writers do every day. They all start from a lengthy content master, and then they need to compare it against an array of sources needed to inform the content. And it's not just the model. People tend to miss this a lot of the time. A project description system should be involved and easily compared. Specific owner and designer preferences that require that base specification to be modified should be able to inform it and be able to do that gap analysis. There's BPM configurators like the one we showed you for USG and Revit plugins that would want to be in there and be able to kind of inform those specs. So we want to make all of those comparable for the spec writer. And what we can do with AI right now is that set it up so every one of these can use a similar classification system for easy comparison, or at least have a lookup table. So right now, the question is, can we adjust a 3-part spec and map its parts using a common classification system? Yeah, we can do that. Can we compare decisions made in a project description system to help us stand up the sections and product types we need? Yes, we can. With AI, can we show gaps between the model and the spec and provide efficient ways to address those issues? We can do that. We can pull in a third-party application and shows where adjustments need to be made to reconcile product decisions from an owner or designer. We can do all these things and compare and make the process very, very easy for the spec writer without trying to take them out, but make sure that all the communication happens through there. And I don't think there's anything here that's terribly complex. Where we're using specific AI technologies, they're fairly far along and fairly stable. So when you really compare a specification to another source, the spec writers is using it to influence it. And you can see the before and after when it happens here. So we're taking a spec and we're saying, all right, it's being informed by this in the model. What changed about the spec when they were addressing this inconsistency? We can use that to actually guide the process of training it on how to make edits to those specs. So eventually that's within reach. So I want to finish with a couple takeaways here, and start off with some of the findings for design firms. So where things are currently, most design firms might claim that BIM's a big part of their strategy. We really don't see much evidence of it, and that really comes through today. And are they using BIM? 100% across the board. Everybody uses Revit. It's pretty key. Are they using it in a way that, for example, influences product selection? Probably not much. On the design bid build side, people still build everything in the same disconnected workflow, and then they review what was built and create the model from scratch just before completion. That's obviously the most common. Often is a requirement for asset management or maybe energy modeling. There's pretty limited growth for design firms with those repeatable processes, and even the examples that I used to have kind of given up on it. So it's pretty slim pickings on that side. And so if you think you're behind the 8 ball from a design firm perspective, I promise you that you're not. We are seeing it more successfully implemented with more design build, where owners kind of control the whole process. But even then, it's limited. If you're a building product manufacturer, we kind of break it into 2 different phases. We've got first phase BIM, where I'm going to post a bunch of objects out there, and then hopefully they make it into some sort of process I don't understand, and it's going to affect product selection. I think by and large, people have realized that that's not the case. We're helping firms pivot to kind of a second phase where they're taking a complex piece of the process, helping architects and engineers solve it, usually through a Revit plugin or other type of configurator, and then we can deliver a coordinated BIM and spec content. And then finally, for future BIM to specs, when you're evaluating a lot of these new AI technologies, please beware that curated demo that looks like it's going to be easy. It's usually going to have a problem when you start using your own data. And be careful about looking for that automated Turk, this idea that it looks like it's AI, but all kinds of magic has to happen to fix the data behind the scenes to make it run smoothly. Another takeaway, there's really no realistic path for fully automated specs originated from BIM. I know for a fact nobody's working on it right now. There's not a single company that believes that's possible. I do think that there's a lot more capabilities, in the pivot we just described. And then hopefully you'll be able to start breaking down AI to different points of the Gartner Hype curve and use that to help explain risk to, the different principles in your decision-making process. And in the near future, and I'll be happy to discuss this individually with people if they want some more detail, more than I can really provide here, is that applications built around the idea from the ground up that the data is always going to be wrong, and use that human in the loop approach to deliver efficiency to users while leveraging their expertise to train the model. That's really what the way forward is going to be. It's just recognizing that we're always working with imperfect data. And if, we take that approach where we can help people correct that data and train based on, how they make those corrections, those are the applications that are going to be our next generation. And more specifically, that side-by-side comparison or gap analysis from different decision points, seeking to inform the spec, I really think is one of the great opportunities out there for kind of the next generation platform. And I think we'll see some movement on that and hopefully some new products before too awfully long. So that kind of brings me to the end. There's a little bit of a reminder here. If you'd like some additional information on SpecLink, our platform here, and the BIM integration, you can reach out to us. We have full collaboration capabilities and free trials. If you're a building product manufacturer, you can reach out to me individually, and I can talk to you about different ways that we can connect up BIM and specs and deliver coordinated content to architects and engineers and spec writers there. So with that, I'm going to leave that on the screen for just a moment here and throw things back to Manish, but we can certainly take some questions. We've run a little bit long on our time and everything, but if we don't get to your questions today or don't have the time, I'll certainly make sure that we respond individually and I reach out to you. So Manish?
Thank you so much, man, for such a elaborated session. It was definitely fun. So I've got some question which came in from Kiran. She wants to ask, how about India? Will they adopt BIM in the future? I think she basically means BIM/AI, collaborative. Do you think it can happen in India as well?
I think it can. I think I would say that BIM, India's way of doing things is more similar to America than some of the things I've seen in Europe. They have a similar type of system and so forth. So I think that's probably accurate. Just to explain my own bias, almost all the developers I work with are on the Indian side of things. I'm a big proponent of just what how deep their technical capabilities and their bench are. So if there's any group that can do it, I would probably put my money on India. Some of the solutions that are underway right now do feature heavily with Indian developers. So without revealing too much, I think that's probably one of the first places that we'll see some of those advancements.
Cool. And there's something asked by Maheshwari Reddy. She basically has a BIM 360 collaborative tool developed and wants to connect with you to discuss further. So I believe you have left you can leave your email. Get in touch with Matt for whatever collaboration. So you want to leave it?
Yeah. Please do. I would invite anybody. One of the things, one of the reasons I love working with RIB is we do a lot of collaboration in the industry. We're trying to make things better for all parties. So I do work with people, and typically, I'm not called on to work with anybody that's really a competitor, but people that are trying to solve a lot of these big issues. I love to get in and see if I can connect you to the right people and say, hey, these approaches have been tried. Maybe you should consider this. So I would absolutely love the opportunity to sit in and see what we can do to help each other out.
Perfect. So, with this being said, let's just end the session because it's short over time. So thank you so much for all the attendees to come in and attend the session. Thank you, Matthew, for such a brilliant session, conducted for great information, next gen technology. I'm sure all these attendees will actually look forward to connecting with you in person. Thank you all. We'll end the session. Matt, you just want to say goodbye to everyone, and Matt. So
certainly, and thank you all for attending. I'm hoping that I'm able to connect with a lot of you on LinkedIn and via email. And I always learn as much from you as potentially you do from me. So if there's anything that I can do to help, that's what I'm here for.
Cool. Thank you so much. God bless, guys.
Good deal.
Take care.
Thanks, everybody.